Hello students, today we will discuss the chapter Biomolecules, and first of all we will study about the carbohydrates, what are carbohydrates and the classification of carbohydrates in different terms. So what are carbohydrates? These are optically active polyhydroxy aldehyde and ketones. And now classification, that is types. There are mainly three types of carbohydrates, that is monosaccharides, oligosaccharides and polysaccharides. So monosaccharides, the carbohydrates which cannot be hydrolyzed further, that are known as monosaccharides. For example, glucose, fructose, ribose. These are very small carbohydrates which cannot be hydrolyzed further. Next is oligosaccharides, the carbohydrates which on hydrolysis gives few molecules of monosaccharides. For example, sucrose, maltose, lactose, etc. Now next is polysaccharides, the carbohydrates which on hydrolysis gives many molecules of monosaccharides, that are known as polysaccharides. For example, cellulose, starch, glycogen, etc. Now on the basis of taste, the carbohydrates are of two types, that is sugar and non-sugar. Sugar, the carbohydrates which are sweet in taste, that are known as sugar carbohydrates. For example, glucose, fructose, lactose, etc. And the non-sugar carbohydrates, the carbohydrates which are not sweet in taste. For example, starch, cellulose, etc. Now we will discuss the another types on the basis of reducing nature. The carbohydrates are of two types, that is reducing carbohydrates and non-reducing carbohydrates. So what are reducing carbohydrates? The carbohydrates which can reduce Fehling solution and the tolerance reagent are known as reducing carbohydrates. For example, lactose, maltose, etc. Actually all the monosaccharides are reducing in nature because either they have aldehyde free group or the free ketone group. For example, glucose, fructose, etc. And these carbohydrates which have free aldehyde, that I have discussed now, that they have free aldehyde and ketone function groups, they show reducing nature. Now what is Fehling solution? We have discussed here that Fehling solution we have discussed here. So what is Fehling solution? And we have discussed in the organic chemistry also. So Fehling solution, actually it is made up of two types of solution, Fehling solution A and Fehling solution B. And Fehling solution A is aqueous copper sulfate solution, and Fehling solution B is alkaline sodium potassium titrate. And when a test is done, then these solution are first mixed and then these are put into the sample to be tested. Now what is tolerance reagent? That we have discussed above. What is tolerance reagent? This is ammonium silver nitrate solution. Now non-reducing carbohydrates, the carbohydrates which cannot reduce Fehling solution and tolerance reagent, that are known as non-reducing carbohydrates. For example, sucrose. In sucrose, the two molecules of monosaccharides are bonded in such a way that the free aldehyde group is not available there, or free ketone group is not available there. That's why they don't reduce tolerance reagent or Fehling solution, and then they are known as non-reducing carbohydrates. Now further classification on the basis of carbonyl group and number of carbon atoms. So on this basis, there are two types of carbohydrates, aldose and ketose. The carbohydrates having aldehyde group is known as aldose, and the carbohydrates which have ketone group, that are known as ketose. The name according to number of carbon atoms also included in the name of aldose and ketose. For example, carbon atoms, if there are 3 carbon atoms in the molecule of carbohydrate, then it is known as aldotriose if there is aldehyde group, and if there is ketone group, then this is known as ketotriose. And if in the carbohydrate molecule there are 4 carbon atoms, then it is known as aldotriose if it has aldehyde group. If it has keto group, that is ketone group, then this is known as ketotetrose. If there are 5 carbon atoms in the aldehyde containing carbohydrates, then this is known as aldopentose, and if it contains ketone group, then this is known as ketopentose. And if the aldehyde containing carbohydrates has 6 carbon atoms, then this is known as aldohexose, and if it contains ketone group, then this is known as ketohexose. Now next we will discuss the preparation of glucose. The preparation of glucose in your syllabus, there are two methods for the preparation of glucose. First is by the hydrolysis of sucrose. This is the formula of sucrose, C12H22O11, and when this is reacted with water in the presence of small amount of acid, then hydrolysis of this sucrose takes place, that is breakdown of this sucrose takes place in the presence of water, and then glucose and fructose are formed. So next preparation is on the hydrolysis, that is by the hydrolysis of starch or cellulose. So this is the formula of starch or cellulose, C6H5O5 and whole N, so NH2O plus NH2O, and in the presence of small amount of acid, this will give many molecules of glucose. N means many molecules. Here N represents the number which is here. If there are 100, 200 number is here, then here will be the 100, 200 glucose molecules. Now next is structure of glucose. The structure of glucose has been assigned on the basis of various reactions. Various reactions were done to know the structure of the glucose, and we will discuss that reaction first, and some of these reactions and their observations are. And in exams, the question on the structure of glucose is asked, and we have to tell the reactions and observation also. We cannot skip the observation part. So observation part is also very important. So we will discuss now the first point, that it has been found that formula of glucose is C6H12O6. So by some method it has been found that the formula of glucose is C6H12O6, and the reaction here is that it is reacted with HI. When it is reacted with HI, then N-hexane is formed, and we know that in N-hexane, that is normal hexane, there is linear chain of carbon atom. So this observation conclude that this observation, that is this reaction, shows that all the 6 carbon atoms are bonded in a linear chain in glucose. So this is the observation of this reaction, and we have to remember this observation also. So next reaction is that we react glucose, this is the general formula of glucose, we react glucose with hydroxylamine, and when hydroxylamine is reacted with glucose, here we can remove the water molecule H2O, and then this N gets bonded to carbon atom and OH with nitrogen atom. So this is known as oxime. The compounds in which this group is present, this is known as oxime. So oxime is formed, and this reaction is due to the presence of carbonyl group. If there is carbonyl group, then only then this reaction will take place. Now next is with HCN. With HCN, what will happen? This pi bond electron. Always remember, each bond, whether it is sigma bond or pi bond, contains always 2 electrons. So these pi bond electrons will come over the oxygen atom, because oxygen is more electronegative than carbon. What is electronegativity? Electronegativity, it is the tendency to attract the pair of electrons by an atom towards itself. This is known as electronegativity. So oxygen is more electronegative than carbon, so it will attract this pi bond electrons towards itself. So this oxygen will acquire negative charge because electrons carries a negative charge. Now because the electrons have moved away from this carbon atom over the oxygen atom, so this carbon will become electron deficient, so this will require positive charge. So H plus ion from this HCN, because HCN is an acid, right? So H plus ion from this acid, it will get bonded to O, because it will be having negative charge. So OH bond is formed, you can see here, and this carbon which will have, after transfer of this pi electron which will have positive charge, it will get bonded to CN negative ion. So here is the formation of CCN bond, and the compounds which have this type of structure, they are known as cyanohydrin, right? And on the basis of these two reactions, we can say that that the glucose has carbonyl group. This group is known as carbonyl group. If there is no carbonyl group, then this reaction will not be possible. Both these reaction will not be possible. So our observation, that is our conclusion, is that we can say that on the basis of this reaction, that glucose has carbonyl group, right? So next reaction is with bromine. Bromine is a weak oxidizing agent, right? So it can oxidize aldehyde group, but it cannot oxidize this. So it oxidizes, that this bromine oxidizes this aldehyde group, and oxidize means oxidation, that is addition of oxygen. Here is now addition of oxygen. You can see is extra oxygen atom than this. So oxidation has taken place, and on the basis of this reaction we can say that there is presence of aldehyde group, that the carbonyl group which is present, that we have shown by the previous reaction, that carbonyl group is present in the aldehyde group. So one aldehyde group is present, we can show by this reaction. Now next is that reaction with nitric acid. We are now reacting the glucose with nitric acid, and nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. So it will oxidize this aldehyde group and this primary alcoholic group. This is primary alcoholic group because this carbon which is attached to OH group is bonded to only one carbon atom. So this is known as primary alcoholic group. So oxidation of this primary alcoholic group and this aldehyde group takes place in the presence of this strong oxidizing agent. So COOH is formed, and here also COOH is formed because of oxidation. Oxidation is also removal of hydrogen, and it is also known as oxidation, it is also known as addition of oxygen. So here is removal of hydrogen and addition of oxygen. So you will get this, and here is only addition of oxygen, right? Now if we see according to this reaction, it means there is one primary alcoholic group is present. This reaction shows that there is primary alcoholic group in the glucose molecule. And if we do reaction with gluconic acid that we have prepared above by the reaction of bromine, this is gluconic acid, not the saccharic acid. You can change it. This is gluconic acid, right? So gluconic acid, when it is reacted with nitric acid, then it gives the same product, and it was already there, so it is oxidizing this. So this clearly shows that the primary alcoholic group is also present in the glucose molecule. Now on the basis of our reactions and other reactions, the following structure glucose has been proposed. This is the complete structure of glucose. Here above CHO, that we have shown by the reactions. We have shown also that there are 6 carbon atoms which are clearly linked to each other, and there is one primary alcoholic group here. So here we write CHO, and that you have to remember other structure. So CHO, here OH, that is on the third carbon, OH will be on the left hand side, and then on the remaining carbon OH will be on the right hand side. In this way you can remember it, right? So OH, H, OH, H, OH, H, OH, H, CS2OH, and here above CHO. In this way you can remember it. Next is which was left above, that the after 5th point you can write down the 6th point, that if glucose is reacted with acetic anhydride, this is known as acetic anhydride. So when it is reacted with acetic anhydride, there is formation of ester. This is the ester part. So there are 4 OH group here, so it will react with this, and there are 4 ester groups are formed, and this will also react with this group also. So here is also ester group. So this is known as glucose pentaacetate. So this reaction shows that there are this reaction shows that there are OH groups which are bonded to individual carbon atoms, because this structure is stable, that is stable glucose pentaacetate is formed. So this clearly shows that Glucose pentastate is formed, and there are 5 OH groups. There are 5 OH groups which we have shown here. There are 5 OH groups present in the glucose molecules, and and this is the stable product. Formation of this stable product shows that there are presence of 5 OH group in the glucose molecule, right? So this is about the structure of glucose. So we will discuss the next topic in the next chapter.